you imagine me as the Network Operations Center, with due respect to my colleagues in the HN and not in the audience, I'm the network guy. I'm not a programmer. I'm not a software person at all. But I'm going to be the user of this system because I have a network I want to build. So what we have here is some of this is quite abstracted away for the purpose of the demo. But there is already in existence. We have the OpenNAS software. You run it and you get a command line. There is also a web services interface API, which is already available. And what we've done here, we've given the demo in the past with the command line itself. Is it not yet over? Yeah. Cool. But what the guys have built is, since the command line is there and working and actually quite feature complete, and the web services API has now been built. How do you demonstrate an API? The next step is to develop the GUI, and that's what we're embarking on now, but we need something to show. So the guys, this isn't just a series of web pages, this is a series of scripts which directly invoke the OpenNAS API and perform the operations that we're going to describe. And we're going to use these images just to show the steps as each goes along. Is it safe for me to hit next? Yeah. Great. Meanwhile, on the other side of the stage, Pao has his laptop set up with a bunch of terminal sessions, which if you want to see the action actually happening, with a log scrolling by, a bunch of pings set up, and of course the OpenNAS command line itself. What we're going to do here, yeah, we have a mic there as well. This one. All safe? Cool. What we're going to do, you're here with me in Iceland, obviously, and we're using just a web browser on a laptop on the network here to trigger these scripts on the web server in Barcelona. These will interact with the OpenNAS API, again hosted on the machine in Barcelona, and that's then going to configure equipment which is based all over Europe, in fact. And I believe that's even on the next page, so I might as well click the button. And the testbed looks like this. Like I said, the OpenNAS installation is in Barcelona. A lot of the equipment that's being configured is in different parts of Dublin. We've got 2 different locations in Dublin, and also there's a router in Copenhagen, which is going to be involved in this demo. And what that's going to look like in more detail is this. We have, within HENet, like I said, there are 2 locations, one in Dublin and one in our Parkwest data center, and we have physical routers in both of those locations. There's also a physical router located in Nordnet in Copenhagen, in UDC there. And the connectivity between these is provided by Giant Bandwidth on Demand. So we're going to be invoking this, like Pao said, we already have a driver in place. We're going to be invoking that to build the connectivity between them. We also have an internet connection shown here on the left-hand side going into the Parkwest side, and we have some content being a webcam sitting in a HE in the data center, and a virtual machine that we've set up which has a web server on it, which we should be able to connect to. We can't right now because the connectivity isn't up, but we should be able to connect to by the end of the demo. So Pao, do you want to take over? I push a button. Yeah.
Okay, first step right now, because we are playing with the... First step right now is, I think, nothing wrong.
What's wrong?
We are playing with an empty instance of OpenNAS. Okay, the first thing that the client simulated interface we're having is load 3 resource descriptors into the OpenNAS instance. Okay, this will send to them XMLs describing. There you have some interfaces, and by there I mean IPs, ports, and credentials to management. Okay, and we want to export these capabilities. So we describe the resource and what you want it to have. Then OpenNAS will take all of these and open connections to all of that resources, make the full config and get the full state of that resource. And by a full state, gives not only configuration data, but also lets know all the chases, how many interfaces do I have, how many logical routers are there already. I'm gonna risk it. I haven't cleaned the database, but
Okay.
It failed, it's gonna fail fast. It's working. Okay, this is gonna take a while. What we can show you here is OpenNAS. I have been open at a single instance here. this is just a fresh unzip of the OpenNAS default distribution. Version 10 is what we are releasing here at TNC. Well, the first thing you get is a CLI. Okay, this is for demo purposes. This obviously runs unattended, and this CLI is exported on an SSH port, so anyone can try it. You can see there are some comments available. Don't be scared. You don't need to know 300 comments for managing network resources. Oh, it's already in step 2. Okay. Around 150 of them are just for managing the actual installation of the platform. So you need them if you want to make clustering, if you want to connect that to an identity provider, things like this. And some of them do talk about SPF, interfaces, and so on. So now OpenNAS knows about the infrastructure. I can make this, for instance, to prove it. OpenNAS has discovered 6 routers. You don't see it here. If you make info about the concrete router, you will see only 3 of them are real physical routers. The other 3 have been discovered because we are running the demo on infrastructure that's being used for other projects. So there are logical routers there, servicing other people, and we don't touch them. We don't need to take full control of the router. We can just work with part of it. Just quick, because it's going to take a while.
Push the button,
Yeah. The next thing, while it's getting done, is actually calling the web service. Look here. Should be moving things. What we do here is to register logical interfaces. So we take ownership, OpenNAS takes ownership of concrete sets. In this case, Ethernet encapsulation everywhere, and takes ownership of concrete VLANs. Okay, it's going pretty fast now. Next step.
That's what we want.
Next step is to create logical routers, managed by OpenNAS inside over this physical infrastructure, and group these interfaces on top of these logical routers. When we do this, we can only create a logical router instance, but we also say that these concrete sub-interfaces are no longer free resources available in the pool. Now they are owned by a logical router, and this logical router is in its turn owned by a concrete user that has some access rights on top of it. So we have instantiated part of the infrastructure now.
What I should be able to do is, if I get the name right, is I can now show you the configuration on one of our physical routers. This didn't exist a few minutes ago. We now have a logic system called Dub defined on this particular router with these interfaces associated with it. No IP addresses yet, just interfaces. We're done.
Okay. Next step is going to create a network. The network is already there, physical network, but this step is going to create this network resource. That's a logical instance inside of OpenNAS. When Dave presses this button, it's going to go very fast, because this actual step doesn't actually go to the physical infrastructure, it doesn't send signal anywhere. It's an OpenNAS only action, but we do group these 3 logical routers inside a single resource called network. What I said before is a bunch of routers plus a topology plus bounds and demand domains.
This isn't just an academic distinction. We're going to come back to this in a little while, because when you're able to deal with the network as an abstract element as itself, then there's some very interesting things you can start to do, and we'll come to that shortly.
Now that we have the network, we're going to set up give some IPs to all the interfaces. In this case, this is what OpenNAS supports right now. We'll tell to concrete interfaces to concrete resources, you get this IP, you get this IP, you get this IP. But the next step is pretty obvious. You have a network, the network knows the topology, knows which routers are there, knows which interfaces these routers have, so you can actually implement a capability on that network, saying, okay, take this network, this single schema, and just put it. I don't want to think, it's just a very short algorithm that separates IPs and puts an IP everywhere, so it's masked correctly, so it's less manual.
This, of course, like I said, this is a real but limited GUI built on the existing API. It's not the way the real one's going to look. However, you don't have to use a real one either. If you prefer to use the API and integrate it into your own tools, use the very same technology that's there right now.
Yeah, in fact, some of the
partway there, that can already show you that router that I showed you a moment ago now has IPv4 addresses configured on each of its interfaces.
User interfaces where many of our use cases differ the most. Some of the use cases that he has mentioned really require an interface like this, a 3-step wizard somewhere that, for instance, a doctor in a hospital needs to go through to provision a given connectivity or access to some private content like we have here. Okay? So yeah, a wizard is not that far from reality, but of course a NOC needs something more than this. So it's done. Okay.
I should push this button now, shouldn't I?
Yeah.
Yeah.
Did it go? No. 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 This step takes like 4 minutes or so. Dave has a presentation to explain what's happening right here. But NAS right now is not doing much. NAS has delegated the layer 2 connectivity that we have to Auto in this case. Okay. I think you can
this is the interesting bit. Step 6 here. It takes a few minutes, and I'll explain why. I'm going to use this. We're using the bandwidth on demand system from Géant, from the Géant project. And how did we get mixed up with this? Well, you might know bandwidth on demand from maps like this. This is the extent of its reach at the moment. And what I'll describe it as is a meta provisioning system for layer 2 networks. Meta, what's so meta about this? Well, it's going to give us bandwidth across domains. And bandwidth is the second half of that equation. We've shown you the routing part. We've shown you routers being created with logical routers being set up and IP addresses being assigned. This gives us the second half of that equation, routing and bandwidth. That's the pairing that we're after. And someone's already done this, so we take advantage of that. The meta provisioning system thing I mean is that each network each NREN already has its own physical network. And they may well have their own provisioning system in place. We do in HEAnet, we call it BlueNet. It's just our system, not saying anyone else should use it. But this thing has its own website where where our NOC can log in and do log in every day and create circuits and delete them and manage them. But we also have an API, and a small portion of that network is exposed to this API. Not the whole lot, only the parts we want external users to be able to access. And the bandwidth on demand system itself, the international system, is a user of that API. And the circuits that it requests are still created by our own provisioning system. They are identical in every way to circuits made by our own NOC. They do exactly the same thing and they operate in the very same way. It's just a matter of the way that the request was formed. That's all. And where does OpenNAS come into this? Well, bandwidth on demand itself has an API, and we use that. If we need circuits between 2 locations, we requested the bandwidth on demand system. So a bit more detail on that. Here's an abstract version of the network as it currently is. And what's going on right now, we have this infrastructure all over the place. So they're each in their own management domains. So we have HEAnet, we have Géant, and we have Nordinet. And what I did a couple of minutes ago when I pushed that button was initiate a request from the OpenNAS server in Barcelona to what we call the interdomain manager inside HEAnet. And that is the upper level system that's responsible for managing HEAnet's participation in the bandwidth on demand system. First thing it does is compute a path, an abstract path on the abstract network between the different domains to get from where we've asked to come from to where we want to go to. Then the second thing it does, once it's worked that out, is since the beginning of that path is inside our own domain, it asks our own system to make those circuits, including, by the way, circuits which lie entirely within the HEAnet domain. Why not? They're endpoints that are exposed, we can use it like that. So it creates these circuits from each of the endpoints we've requested, and where they end in another NREN, it completes them as far as the Géant border. And at that point, watch the top here, it then passes a request to the next interdomain manager, the next domain along in the path, which does the same thing. It passes the portion of the request that's important to its own domain manager. It makes a link from border to border. In this case, we now have a link from London through Paris to Amsterdam to get to our Nordinet. Now, extra thing to handle here. What if we have a router, which we do in this case, which isn't connected to the on-demand system? We can cope with that too. We have these circuits already created with the VLANs to match, and what we managed to do is, and at this very moment as I speak, we have circuits being made dynamically from 2 locations in Ireland, through Jayant, through London to Amsterdam, where they meet with the already existing circuits, which bring them onward to Copenhagen. And how's that going? They're finished.
Yeah. So right now, layer 2 provisioning is done.
Yeah.
So right now, layer 2 provisioning is done. So we have the layer 2 visibility among the infrastructure. The IP configuration is done. The only thing we need is a dynamic routing protocol activated. We can very well click here, and this will send a call to open NAS and activate OSPF in all the network. But I think they want to do this in another way.
Are we okay for time? Yeah, okay. Oops. Got another button here. I wanted this bit myself, thank you. Because I've been testing this out myself, obviously, over the past few weeks and making this work. I think this, can I still be heard okay here? I think this shows very well the power that's in here. We had as Pao explained earlier, we had the IP addresses singly graded, and we have the circuit singly graded. But one of the things that we are able to promise here is some sort of automation. Now, you remember earlier I said let's make an abstract network. Here's where we get to actually use that. I issue a single command here, OSPF activate, and then I apply it to the network we just created.
Yeah. I take the inside. This is the resource ID. This is the resource ID. So when we talk about resources, if you make resources list, you will see now we have 6 routers as we had before and a network. This is the ID of the network, and this is the capability that's calling a concrete functionality on this resource. You have seen it's gone very fast, because the only thing it has done right now is to QE an action for activate OSPF on this network resource. On this resource is QE. So it's not actually activated yet. It's on the QE. So you can QE list or QE execute. Which actually perform the actual configuration. Okay? The nice thing of the QE, and in this case this distributed QE, is that if the configuration fails, if in any of the 3 routers, all 3 routers will be rolled back. So you will not end up having OSPF activated in half of the network and half of the network without OSPF.
There it is. So what's happened here is, from the actions we already took, the software was able to infer and keep track of the shape of the network that we had created, and we just come up with it on our own here. It could have been any other shape, and bring up OSPF on all those interfaces on all 3 routers, and it took a single command to activate that. There'll be more if you want to customize that, obviously. But it's possible for us to say there is a default, sensible, best practice state that most people will want to use most of the time, with the following parameters to tweak. But if you do it on its own, if it's 1 router or 3 routers or 100 routers, we will bring it up across the entire network. So, I get to push this one.
So we have, should the CAM already be available, right?
Oh yeah.
I can show that. Wait a minute. We have layer 3 network, layer 2 network below. We have a layer 3 configuration. So we have a fully functional IP network. As we have set up public IP addresses on this network, it's reachable from the internet. So what Dave is doing, you can actually do that on your computers if you want. Just put that commodity DNS on your browser, and you will go to this very private and specific content that's the webcam.
It's a Sunday. It's dark in the data center.
It's very dark. Yeah. So this is exported through the internet via this private IP network we have created that we own and we can manage. Okay. Next step is to activate Jarvis tunnel We just did it for the sake of showing gyro fusion. It doesn't make much sense network-wise. But this VM is joining our IP network via gyro tunnel. Okay, we targeted this functionality very early because it's important for us that clients can join IP networks even if they don't have, they are not suited to have layer 2 connectivity to the network. So let's do it.
We're done.
We're done?
Yeah.
Done already?
Yeah.
So we should see right now.
Like I said earlier, we have a web server running on this virtual machine, which is only connected via the GRE tunnel, and the troll is dancing. I'm pleased to report.
That's it. You can click the 0 now.
So all that network is currently working, and now it's going to stop working. And those resources will be freed up for the next person who's going to use it. It will be me on Tuesday.
Yeah. Well, this takes a while because it's everything on reverse. Let's just pull out when it's finished. So I think it's time to ask for questions, or this is open.
But that's a demo. Thank you very much. Any questions?